Welcome to Patrick Talks Physics. As you can see, our topic today, kinematic equations. Oh, those kinematic equations. They can be tricky, but there are some fantastic strategies that we can consider to help make them a little bit more understandable. So let's take a look. So our word kinematic has a wonderful Greek prefix at the beginning, K-I-N-E, which means movement. Think of words like kinetic, kinesiology, kinematic. These words all imply movement, so we're looking at movement equations. All of our kinematic equations are made up of, let's call them variables, and there's 5 of them. We have displacement, which is measured in meters, time, measured in seconds, acceleration, measured in meters per second squared, and initial velocity and final velocity, both measured in meters per second. One thing to keep in mind when looking at kinematic equation problems is that units are helpful. These units will help to identify what we have and will help us to figure out what it is that we need. Now I like to do this thing where I organize everything excessively. So let's take a look at our 4 main kinematic equations. You'll notice on this chart that I developed, all 4 kinematic equations are listed on the left column here. First one, final velocity equals initial velocity plus acceleration times time. Our second one, displacement equals initial velocity times time plus 1/2 acceleration times time squared. Third one, final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. And our fourth one, displacement is equal to 1/2 initial velocity plus final velocity times time. As well, you'll notice that all of our variables are listed across the top, and I've highlighted which of these variables are involved in every single equation. So for example, in our first equation, initial velocity is present, final velocity is present, acceleration is present, and time is present. Now why is this going to be helpful? Well, you'll notice here that we are missing displacement. There is no check mark here in this first equation, which indicates that this variable is completely irrelevant to this equation. And as you look throughout the table, you will notice which variable is completely irrelevant in every single equation. This is helpful because it'll help us to identify which equation it is that we need to use for a given problem. All we really have to do is figure out which variable is not present. This can be extremely helpful, but there are 4 other things that we need to consider with every kinematic equation problem. We need to ask ourselves, what do we know? Secondly, we need to ask ourselves, what do we need? We also need to ask ourselves, which equation should we use? And then we need to go for it. And before we go for it, we need to keep in mind we have to find 3. Big important thing to remember. What do I mean by that? There are 3 variables that we need to have in order to find a 4th. Once you've identified the 3 variables you need and the 4th one you need to find, that'll help you find your equation. So let's take a look at a simple problem. So our problem here reads, an airplane accelerates down a runway at 3.20 meters per second squared for 32.8 seconds, then lifts off the ground. How far did it travel before takeoff? So let's take a look at our units in the problem to see what it is that we have. As you can see, we have something in meters per second squared, which is an acceleration. So I'm going to write down acceleration equals 3.20 meters per second squared. Secondly, I do have a time, which is measured in seconds. So I'm going to write down that time equals 32.8 seconds. Now we get to a point where something can get a little confusing. Remember, our goal is to find 3. We need 3 variables in order to find a 4th. So what is that 3rd variable? Well, if I consider an airplane, probably is starting from a standstill. So that is my initial velocity, which will be 0 meters per second. And what is it that I have to find? The end of the question asks us, how far did it travel? So what we need to find is a displacement. So we have 3 variables. That's our goal: acceleration, time, initial velocity. And notice that final velocity is completely irrelevant to the question. It's not given to us, and it's not something that we need. So now if we take a look at our fantastic sheet of kinematic equations, we need to find an equation where final velocity is completely irrelevant. And here it is right here. So this is the equation I'm going to use to solve for my displacement. let's write down our equation and let's see if we can solve the problem. Now keep in mind, our equation was displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. Let's fill in the variables that we know. I know that the initial velocity is 0, so we have 0 times, time, that was 32.8 seconds. We're going to add that to 1/2 of our acceleration, which is 3.20 meters per second squared, times our time squared, which is 32.8 seconds. Now solving this isn't quite as bad as it looks. Since we have 0 right here, anything times 0 is just 0, so that cancels out of our equation. So let's rewrite what we're left with. So we have 1/2 of our acceleration, 3.20, times our time squared, which is 32.8 seconds squared. After some trusty solving with a calculator, our displacement is going to be 1,721.3 meters. Now you'd think we're done, however we need to respect those wonderful things called significant figures, and here I have 3 and 3. 3 digits in each of my variables that I've been given, so my answer needs to have 3 digits in its answer. So the most appropriate answer, 1,720 meters. Congratulations! You just solved yourself a kinematic equation problem. Before we take a look at a second and harder question, let's keep in mind what we did here. Remember, find 3. So important to find 3 variables before we do anything else and answer these 4 questions. What do we know? What do we need? What equation will I use? And then we go for it. So here's our next question. A kangaroo can jump to a height of 2.62 meters. Determine its vertical takeoff velocity. We can see why this is going to be a harder problem, because if we look at the question, there's only one variable, and that's the displacement, right here, of 2.62 meters. And let's also indicate that it's up, because it is a vertical takeoff speed after all. The only other thing I know for certain from the problem is that I have to find the vertical takeoff speed, which is the initial velocity. That's the variable I have to find. Well, I need to find 3 variables in order to find a 4th. So what are these other variables that I need to find that are implied in the question? Well, it's kind of like a free-fall question. So something to consider is that likely at the top, we are going to have a final velocity of 0 meters per second. We come to a stop and then fall back down. Also, gravity is involved here, so that's going to be my acceleration, which is 9.80 meters per second squared. Well, and here we have another thing to consider, reference frames. Gravity is downwards, so I'm going to consider down to be negative. And since my displacement is up, then I've got to acknowledge that that is going to be positive. Well, it looks like I have my 3 variables, and it also looks like time is completely irrelevant to this question. So let's take a look at our trusty chart and see where time does not appear in one of the kinematic equations. And this is the one I'm going to use. Looks like I'm going to have to rearrange to solve for my initial velocity, but let's write the equation down first. So what we have is final velocity squared is equal to my initial velocity squared plus 2 times my acceleration times my displacement. So let's plug in what we know. We could start off with our final velocity, which is 0. And of course, that's going to be equal to our initial velocity squared, which is what we want to find, plus 2 times our acceleration, which is minus 9.80, times our displacement, plus 2.62. Don't forget the plus and minus signs, as these are going to be hugely important later on. Well, now it's time to simplify. So we have 0 is equal to our initial velocity squared, and we can multiply all the rest of this out, and what we end up with is minus 51.3. Now we can take this minus 51.3, bring it over to the other side, and that's going to make it a positive 51.3. So that means 51.3 is equal to the square of our initial velocity. The only thing we're going to have to do next is take the square root of both sides so that the initial velocity is going to be equal to square root of 51.3, which is equal to 7.17 meters per second. Now, of course, this isn't quite our final answer, as we have to respect significant figures. So in the question, I see 3 digits as the only bit of data I've been given, so my answer has to have 3 digits as well. So 7.17 meters per second is a perfectly acceptable answer. Well, and that's kinematic equations. So what have we learned overall? There's a couple important ideas to keep in mind. The most important which is find 3. Once you know 3 of your variables, you'll be able to find a 4th. Always ask yourself, what do we know? What do we need? Find your equation and then go for it. Thanks for listening, and check back soon for more videos covering the wonderful world of physics. Leave a comment below if you have any questions that you'd like me to go over. Thanks.